Hey geometry team, this is Mrs. Cerna and welcome to Unit 4. We are going to be doing triangles and hopefully this is going to be something that's a little familiar because you've likely already learned a lot of these terms about triangles already, and this should just be a little bit of a review for you with maybe a little bit extra thrown in. So let's jump right into it. So we're going to start off with our triangles, classifying them according to the number of sides that are congruent. And so according to sides. Now on this one, you notice that nothing is marked as being congruent. We don't know how long any of the sides are compared to anything else. When you see this happen in a triangle, that is going to be called scalene. And so let's make sure I'm here. Come on, buddy. There it is. So scalene triangles, none of the sides match up. Ta-da! No congruent sides. That's all we know about them. On this one, we call this isosceles if it has two congruent sides in it, and only two. Okay, a third congruent side, we do something different with that. So isosceles is always just exactly two congruent sides. And if there are two congruent sides, there will always be two congruent angles directly opposite them. So we'll have two sides that match, two angles that match, one side that doesn't, and one angle that doesn't. Okay, that's isosceles. Then, of course, everybody's best friend from when you were in kindergarten, the triangle with all three sides congruent is going to be your equilateral. Lateral means side, so equal sides. This one has all three sides congruent, but just like with this isosceles guy, if you have sides congruent, you have angles congruent, which means that this is going to have all three angles are going to be congruent as well, which gets the fun name equiangular. Ooh, ah. Okay, and that's going to lead us into the next way we can focus on classifying our triangles. We can focus on looking at the sides, or we can focus on looking at the angles. So now we're going to ignore how long everything is and talk about the angles. Here, I don't have any angles marked as being congruent. I don't know anything about how big they are, but in every triangle, I'm always going to know that all three angles together will add to 180. So they will always add to 180 degrees, okay? And so in this guy, we're going to focus on them all being acute. These guys, I don't know how big they are. All I'm going to do is promise you that they're all less than 90 degrees. If you have that happen, then we're going to call that an acute triangle, okay? Acute triangles, all that means is that they have three angles acute. Okay, so that equilateral one we had, it's technically acute triangle because all three angles are less than 90, okay? Acute, aw. This guy has my little right angle symbol in the bottom. So this is called a right triangle. Now the thing about these triangles is since they have to add up to 180, and if you have this one being 90, that leaves 90 degrees being spread out for these two guys, so they're automatically going to be acute. So this triangle has one right angle, but then it always is going to have two angles that are still going to be acute. Okay? So we focus on the one that's special. Whichever one's special, if it's right, it makes our triangle a right triangle. This guy over here has one obtuse angle, bigger than 90, so we're going to call this an obtuse triangle. And again, noting that since one is obtuse, in order to make this add up to 180, if this is bigger than 90, these are going to be even smaller, so they're even more acute. So I still have two angles being acute, but that one that's obtuse is the one that names it. Because everything always has two acute angles. The one that has a third acute angle is acute. The one that has the third angle being right is right. And the one that has the third angle being obtuse is obtuse. You're very impressed, I can tell. So up here, we've got this little thing where we just talk about how big these different angles and different triangles are. So over here, I have my equilateral triangle. And you notice that if it's equilateral, it's automatically equiangular. That's the only way it can be. And incidentally, if it's equiangular, out of 180 degrees, if I take that 180 and divide it evenly among all three angles, each one of these is always, for the rest of your entire life, always going to be 60 degrees each time. Every time. Just memorize it, know it, love it, live it. okay? But then we get into these other guys. Here, I have a right triangle here, because there's my right angle, and then this one, I have a right triangle here, okay? Based on my angles, these are both right triangles, but this guy, I'm going to start with this one actually. This one has two other angles that are both acute, but they're both 45 degrees. If the angles are the same, then I know that this side and this side are going to be the same. Well, I have two congruent sides, boom, it's isosceles based on its sides. So I have a right isosceles triangle here. This right triangle has two different other angles. If these angles are different, then these two sides are different. And so these two are different. The third one is already for a third size of angle. I've got 55, 90, and 35. If the three angles are different, the three sides are different, and it's scalene. So I can have a right scalene, or I can have an isosceles right. And either way, you just look at what the angles are doing and what the sides are doing. On this guy, I have an acute 59, an acute 60, which means this one's going to be 61. That's three acute angles, so it's an acute triangle. But since all three angles are different numbers, I know that all three sides are different lengths. And since the sides are all different lengths, I've got a scalene triangle here. Whereas this guy, I know that they're all acute. I've got 70 and 70 makes 140. And to add up to 180, this guy would have to be 40 degrees. So I know I have three acutes, but since two of the angles are the same, I know that these two sides will be the same, which makes it isosceles. So I can have isosceles acute, and I can have scalene acute. So two different ways to classify. You got to pay attention to both things. Here I've got an obtuse angle here, so automatically I know it's an obtuse triangle without looking at anything else. But I see that this is 100 and this is 30. I know it's kind of small. Well, if this one's 100 and this one's 30, this one has to be 50. Three different angles is going to mean three different sides. And so that's scalene obtuse. Okay? This guy, I've got 44 and 44 makes 88. And so this guy is going to have to be 112 in order to add up to my 180 that I know every triangle has to be. So now I've got two congruent sides. Boom, it's isosceles. But since this guy is obtuse, it's isosceles obtuse. Now what about all these guys over here? Well, if I'm equal angular, the only kind of sides I can have are equilateral. And then if I'm equilateral, I cannot be right or obtuse. Now here's the special thing. This guy right here is acute. Yes, equilateral triangles are a special kind of acute triangle. But since it's special, if you ever see one of these, you want to say the most specific name possible. So since it's equilateral and acute, we go ahead and say that it's equilateral, and that just implies we already know it's acute, but now we're even more special. We've got all three angles aren't just acute, they're also the same size, they're equal. So heads up, word to the wise, know it that yes, these are both technically acute, but we use the more specific name anytime we can. Well, what are we going to do with all this stuff? We have to do more than you did in kindergarten. So now we're going to start naming everything, okay? So in an isosceles triangle, we get to start naming the parts, okay? Now, triangles have three sides, but if two of them are the same, they get special names. Those get to be called, well, I skipped something, so I'm going to skip to it. These are going to be, the congruent sides are the legs. Just like when you stand up, you've got two legs that you're standing on that are theoretically congruent. And so these are the two here. Now, just like if you lay down, your legs, even if they're pointing sideways, are still your legs. If I were to tip this triangle over, the two congruent sides would still be the legs, even if it's not standing on them. Now, the angle that goes in between these two congruent sides is called the vertex angle. So it's extra special. Good luck. And then, so we got our vertex angle, in between our congruent legs here, unfortunately, we don't get to have anything called feet. That would just be way too fun. Instead, these angles that are congruent at the bottom are called your base angles. And they're the base angles because if you were standing on the legs, they would be on the bottom at the base, which means guess what this side is called? Yep, it's the base. Okay, so I have a base, which is the side that doesn't match. I have the base angles, which are at the feet of my congruent legs, and then I have a vertex angle on top. Okay, so in this isosceles triangle, let's say we know what all those parts are. I say, oh, I've got one leg is 20. Gee, I wonder how long this other leg is. Well, since it's isosceles and these are marked congruent as the legs, this guy automatically is going to be 20 degrees. I know it because it's the leg of an isosceles triangle and they're congruent. Then I need to find out angle Y. This is where you have to go back and remember, I know that triangles add up to 180. So I've got this guy's Y. Well, this is one of the other base angles. It has to be the same, so it's also Y degrees. This guy and the 80 degrees have to add up to 180. So I'm going to write that down. The Y plus the 80 equals 180. And then you just do your algebra. Let's figure out what this Y is. I'll take off the 80 from both sides, and I'll combine my terms in the same step, and I'll have 2Y equals 100. So when I divide by the 2, my Y comes out to be 50 degrees. So I've got 50 degrees right here. 50 here, 50 here, that makes 100 plus the 80. Yep, that's the 180 I need for my triangle. You're very impressed, I can tell, because that was just so difficult. So let's make it worse. Now I have an isosceles triangle where I have side LM equals 20, and the measure of angle L, that's this guy up here, is 50 degrees. Now I still need to find X and Y. So I go, okay, the sides are easier. I'll stick with the sides. Oh, it's isosceles. These guys are congruent. So if this one's 20, this one has to be 20. See, you're impressed. You can do all the hard stuff. Now we come down to the angles. I want angle Y, and I know this top angle. Well, this is, again, where we go back to remembering that triangles add to 180 degrees for all their angles. So we'll do the 50 plus this Y plus, oh, these are my base angles. They're marked as being congruent, so this one's also Y, adding up to 180 for the whole triangle. And so let's do the same thing. I'll subtract the 50 off my sides and combine my terms. 2Y is 130. Now when I divide by the 2, my Y comes out to be 65 degrees. And there you go. All right? So know that your triangles add up to 180 and know that the base angles are congruent. You can find anything you need in an isosceles triangle. Okay? Now we're going to go to our equilateral triangles. With our equilaterals, we know that all three sides are congruent. We know that all three angles are congruent, so we can use that to solve problems. If I know that all three sides are congruent, I can find X by saying that this 30 had better equal my 2X plus 10. They've got to be. They're congruent. I subtract the 10 from both sides. 20 equals 2X, divide it off, and X has to be 10 degrees. Or not degrees. This isn't an angle. It's a side. So it has to be 10. Let's check it. If I put 10 in here, 2 times 10 is 20, plus the 10, yep, this side would be 30, which matches this side. See, algebra works even when you're not in algebra class anymore. Then you come down here, and I need to find all the angles. Now, you can approach this a couple ways. You could say, I know that they're all congruent, so this one's 2Y, this one's 2Y, and this one's 2Y, so they all have to add up together to make 180. You could go that route, or you could remember what we mentioned earlier, that, oh yeah, equilateral triangles always have 60-degree angles every time. So I could just say that that 2Y equals 60 and save myself a couple of steps of work, because now I can just divide off the 2 and Y equals 30. Either way, you're going to get the same answer. Do whatever helps you get it right. If you can't remember that it's 60, use that they add up to 180. It's all going to get you there in the end. One more example here. Now I've got an equilateral triangle with even more letters, just to make life fun. So you remind yourself, since it's equilateral, I know all my sides are going to be congruent. So the 5x minus 5 side had better be the same size as 2x plus 10. So I'm going to algebra away. I'm going to combine my terms. And I'm going to get 3x minus 5 equals 10. I add in my 5, and 3x equals 15. Divide it off, and x comes out to be 5. Now let's just double check that to make sure we didn't screw anything up, because you just know that's going to happen. So if I put that in here, 5 times 5 is 25. Take away the 5, gives me 20 for this side of the triangle. If I put in the 5 here, 2 times 5 is 10, plus 10 is 20. Aha, my sides are congruent just like they were supposed to be. Aw, it worked. Now let's check our angle, and I was supposed to delete this and I didn't. Good job, Mrs. Serna. So you go again. Oh yeah, one of the angles of my triangle, if it's equilateral, it's always going to equal 60. So you can take this shortcut to finding your answer. Subtract your 10, 5y is going to equal 50. So when you divide out the 5, and I'm running out of space here and it's all in the dark and you can't see it, but if 5y is 50, y is going to equal 10 degrees. Now let's go back and check. We knew that this was supposed to be a 60-degree angle. So let's check to make sure the 10 worked. 5 times 10 is 50, plus the 10, yep, that made 60, so we found it. So here you see how you can use all these properties of our different kinds of triangles to find out different data. So go forth, calculate, do the stuff, classify your triangles, and we'll see you next time.